You guys look at your notes at the very first question. Ask you find the derivative at 8. Okay? The derivative at 8. Um, the number one thing that students do wrong is they plug in the 8 first. Okay? If you plug in the 8 first, so let me go ahead and plug in 8. If everywhere there's an x, you plug in the 8 first. Do you see whatever you get here? Do you see it'll be a number? I mean, I don't know what it is. So let's just say it's 36. Okay? And then you take the derivative. Okay? No matter what, you're going to get 0. Okay? So you cannot do it in the wrong order. The order is just like the order of that government facility that monitors your food, FDA. Okay? It is not FAD. Okay? If you do FAD, that's just a fad. That's not going to last. Okay? You got to do FDA for it to work. Everyone good with that? So I get very few students do this, but I do get students do this, and they're not, well, I don't understand. My answer is always 0. Of course, the answer can't always be 0. Okay? So first, guys, if you need to take the derivative out of a number, first you have the function. Then you take the derivative. Okay? So go ahead and do that, guys. You should be pretty fast at taking the derivative with a power rule by now. And then you plug in your a. So whatever your constant is, you plug that in, all right? Or I don't know, whatever that number is, you plug in. So now everywhere there's an x, I'm going to put in an a, an 8. Okay? And then you're going to multiply it out. Make sure you guys know exponents before multiplication. All right? So this is going to be 6 times 64 plus 48 plus 7. And I don't know what that is. Okay, but whatever it is, it's a great answer. Okay, on any free response question, so I'll say this again, on any free response question that I give you on a test, unless I say otherwise, you can leave your answer like this. Does that make sense? You don't have to multiply out. If you do multiply out and you get it right, great. Okay, if you multiply out and you get it wrong, then you'll get minus a point. Okay, sad. But sometimes some students just really like multiplying out, and I'm totally fine with that, okay? And sometimes you'll have a calculator, so you should get it right. If it's multiple choice, then of course you will have to multiply out, okay? You won't have a choice. But if it's free response, I'm happy as long as you get all the numbers in with the pluses and minuses. I just know you know how to do the calculus, all right? Any questions on that? Fine with it. All right, so then yesterday we said, problems can get harder. You might have to rewrite before you find the derivative. So if I had this problem, how would I rewrite this to make it a little bit easier? Which part would you rewrite? This one? This would change to x to the -2, right? And now all the x's are in the base. I don't have any fractions, so I can go ahead. And I thought I got to do one problem, but guys, look at this. Oh boy, oh boy, oh boy. I get to do 3 problems. You're welcome. Okay, so we're going to do 3 problems. As long as terms are strung together with plus and minus signs, you can do 3 problems. If they had multiplication, that would be a different story. So we're going to talk about that today. But these are just 3 terms, 1, 2, 3, strung together, all with plus signs. So I'm going to take it one at a time. So the derivative of x to the 3/5 is 3/5 x to the, what power did you get up here? -2/5. Are you comfortable with that? Okay, then you could just carry down the negative. Okay, that's one way to think of it. Or another way I could think of it is this a -2 coefficient. -2 is being multiplied by everything else in this term, okay, that I'm about to take the derivative of. So I can pull out the coefficient, which is -2, and then take the derivative of sine x. What is the derivative of sine x? Is it negative or not? Does this s start with a c? No, so you don't change the sign. Okay, so this is going to be cosine of x times the derivative of x, but the derivative of x is just 1, so I don't have to put the 1. If you can, you can do it, but I don't want you to put the 1. I mean, you can and then simplify it. Your final answer, I don't want the 1 there, because I want you to know that 1 times anything is itself, okay? And then finally, take the derivative of this last term, and you guys jot it down quickly while I jot it here, and they can see if you get the same answer as me. Did you get it? Okay, so this is taking the derivative of 3 separate problems, but it was just one problem. oops, no, sorry, we need to plug in 8. So let's go ahead and plug in 8 here. If I plugged in 8 here, everywhere there's an x, you're going to plug in 8. Okay, FYI, actually. Before I even plug in 8, I'm going to get rid of all of these negative exponents. When expressions are not simplified, it makes it very hard to plug in numbers. So this is going to be 3/5 x to the 2/5 minus 2 cosine x minus 2 over x cubed. Are you good with it? I'm just kind of undoing the rewriting, if that makes sense. So I'm rewriting it so I don't have any negative exponents. And then now I'm going to plug in the 8. So that's going to be 3/5 times, okay, this one's a little bit hard. This is the root of 5, the power of 2, right? So another way to write this is the power of 2, the 5th root, or you can actually say the 5th root to the power of 2. Okay, both of them are equivalent. It's kind of funky. Like it's hard to believe they're both equivalent. But if you play around with this, you'll see that both of these are actually equal to x raised to the 2/5. Okay, so either one is fine. So I'm just going to, I don't know, I'll just choose one. This is going to be the 5th root of 8 squared. That's what this is. I just chose this one, but it didn't matter which one I chose. Where the 8 is, where the x is actually in 8. This is minus 2 cosine 8, and then finally 2 over 8 to the 3rd power. Okay, students hate it when you have cosine of some number that's not on your unit circle. I don't know if you guys know this, but the unit circle, it's just like some key numbers. There's actually a whole bunch of, like an infinite number of like numbers on that unit circle. We just do the 30, 60, 90, 30, 60, 90 because we like triangles. Okay, but really, and we do the 45 because we like 30, 60, 45 triangles. But really, the unit circle is limitless. You could get every number in between, every angle in between. All right, I'm going to stop right there just because I don't want to have a hernia right now. But this is a great answer for your test, okay? The other thing I want to tell you guys is this right here is in radians. It's not in degrees. So if you ever actually even put this in your calculator needs to be in radian mode. And if you're in physics this year, your calculator might not be in radian mode, okay? So to get your calculator in radian mode, all you do is reset your calculator. Anytime you reset your calculator, it goes to radian mode, all right? And in calculus, we'll always use radian mode. We'll never use degrees, unless we're just trying to relate it to degrees, but your problems won't be in degrees. Okay, so if you had a problem like this, you could do L'Hopital's, except you don't know L'Hopital's yet, okay? And so if you look at this, I don't know if you see it, but it looks a lot like the definition of what? The derivative, right? It looks a lot like the definition of a derivative. On Tuesday, you're going to have a formula quiz. You need to know that this is actually a formula for the definition of the derivative. It's called the alternate definition of the derivative. It's always at a point, whereas the h to the 0 one, that one's not, it could be at the point or not at the point, but this one's always at a point. So we always put c there. C is always the same number. So if you notice, c is 8 here. So watch, if I made this 8 and this 8 and this 8, okay, it actually ends up looking exactly like this problem because this says everywhere there's an x, plug in 8 to my function. If I plug in 8, do you get 2 here? So if I plug in 8 there, I do get 2. So this really is the definition of a derivative. So I do f d a. Can you look at this and tell me what my function is? Can you pull that function out? This is the hardest part about doing the definition of a derivative. What's the function? Right here. Right? It's f of x. It's right here. That's a cube root of x. So f of x equals the cube root of x. I'm about to take the derivative, so I'm going to rewrite this in a way that I can take the derivative with a power. What is the power here to the x? 1/3. Okay? Then the derivative will be 1/3 x to the, can you tell me what that new power will be on the derivative? Nice, negative 2/3. Okay? And then I'm going to plug in the a, but it's really nice if you simplify this, that means no negative exponents in order to plug in the a. So I'm going to change that to x to the 2/3 in the denominator, so I have no negative exponents. And then I remember that this is really the same. squared cube root. So this would be the cube root of x squared. Another way to write that would be the square of the cube root. Okay, so again, either or for this, the 2/3 fraction is either or of these things. And then the a means I plug in, so what I'm doing is everywhere, I'm going to clarify that, I'm plugging in 8. So everywhere there is an x, I'm going to plug in 8. So this is going to be the cube root of 8 quantity squared. And what is the cube root of 8? Do you know that off the top of your head? 2. What if I take 2 and square it? 4. So this will be 112. Okay. Just to show you guys that if I had done this, it'd be the same. Let me pull this down. This would have been 1/3 times 8 squared. So this would have been 8 squared, the cube root of that. So that would have been, what's 8 squared, guys? 64. Does anybody know what the cube root of 64 is? 4. So you also get 112. Okay, so just to show you that these things really are the same. Okay, do you feel like you could do that on your own? Okay. So I want to do this problem, which students have a lot of trouble with. This one. And maybe I should differentiate. Okay, I'm going to write this, and we're trying to find the derivative of that. But let me just pull back limits, because a lot of times when we start doing derivatives, students forget limits. So let me do the limit as x goes to, I'll do pi of e squared. Okay. Do you remember what this answer was way back when? It's e squared. Do you remember that? That answer is e squared. Okay. Let's go back to this one. We're going to take the derivative of e squared. Okay. So work with me here. 2 times 1 is 2. Carry down the e. Take the power down by 1. You feel good about that?
No.
No. What's wrong? What did I do wrong? There's no x. Do you see the x? The power rule, when you do the power rule, you need to be very conscious of where your x is. There's no x here. The x is really x to the 0, right? It's e squared times x to the 0. So now what's your derivative? 0. 0 times e squared is 0. Carry down your x. Take the power, I don't know if you take the power down by 1. I don't know if it doesn't even matter. You're multiplying by 0, okay? And so this answer is actually 0. Do you see why it's not 2e to the first power? And a lot of students will do that. But this is a constant, okay? And the derivative of any constant is always going to be 0. All right. Okay, so that's the power rule. And then we talked about the sum and difference rule in derivative land. And this also works for limit land, where if you have a bunch of terms just strung together with pluses and minus signs, that's just, oh boy, okay? Get excited. Someone who's having trouble. So are you having trouble, Austin? Okay, so it's x cubed plus what?
Plus 5 over 4x.
Plus 5 over 4x. Do you have x equals 1 here, Austin? Okay, so we're going to do Austin's problem, but your problem would be very similar, all right? Here you want the equation of the tangent line. So what 2 things do you need when you see equation of a tangent line? You should write on your paper. What 2 things do you need? Point and slope. All right, so we're going to write that down. I need the point, and that just means I need an x value and a y value, okay? And I need the slope, and that just means I need the slope of the tangent line as a number form. Okay, so let's get the point first. Do I have an x value? Yes. How do I get the y value? I know x is equal to 1. How do I find the y value if I have the x value? Plug it in. So do I plug into the derivative or do I plug into the function? Function, because there's a y right there. So do you see y would be 1 plus 5 over 4? So I'm getting 3 halves. Can you check me on that? Okay, right? Because I'm putting 1 right here, 1 cubed plus 5 over 4. That's 6 fourths. Okay, so I have the x and the y. I'm good. The slope right here, and let's just think about what this is. I really don't know what this looks like, okay? But it's some sort of function with the vertical asymptote at 0. So I'm just going to grab something, okay? So something like this. And I know that if I go to 1 and I go up to where the graph is, and I get closer and closer and closer, so close that this point right here looks like a line, and I draw a tangent line right there, okay? The slope of this tangent line, or I'm sorry, the equation of this tangent line. So the equation of this tangent line is what I'm trying to find, right? That's the equation of the tangent line. So I'm just saying, what is this y equals mx plus b? Tell me what that is, all right? So in order to get the equation of the tangent line, I need the point I've got the point, so this point right here is 1 comma 3 halves. I also need the slope of this tangent line. What did I say?
Slope.
The slope of the tangent line. When I say derivative, you say
Slope of the tangent line.
So what is the slope of the tangent line? It's the derivative. Okay, so right here, I'm going to take the derivative. So I'm going to take the derivative of this function. So that's x cubed plus 5 over 4x. Now you don't know quotient rule yet. So today after we do quotient rule, there'd be another way to do this. But right now, you need to figure out how to take the derivative of this with all the x's in one line, if that makes sense. No fractions. So what I'm going to do is I'm going to take this x and I'll move it up to the top. But if you move it to the numerator, do you see it's x to negative 1? And do you see that this x cubed plus 5 was a family before the x to negative 1 arrived? Okay? So are you going to break up this family? Okay? Do you break up families in calculus? No. Do you break up families in real life? No. So we're not going to break them up in calculus either. Okay? So this is a family. So what you're going to have to do is you're going to have to distribute this x to negative 1. What about this 4? I don't know if you see it, but you see it's a coefficient? It's a coefficient. But it's not a 4 coefficient, it's a 1/4 coefficient, right? I could pull out this 1/4 and see that this is really x cubed plus 5 raised to the x negative 1. This is equivalent to the expression that I just had up here. It's the exact same thing. And I'm going to take the derivative of that. And if you have a coefficient, that means this thing is being multiplied by every single thing here. Is this 1/4 being multiplied by all these things? It is. It's this 1/4 times this, okay? Then you're able to pull it out of the derivative. If I had had a plus sign right here, so if I did, if there'd been a plus sign here, okay, or a plus sign right here, okay, if things weren't being multiplied together, then I could not pull out that 1/4. Okay, but the 1/4 here is just a factor, so I can pull out the 1/4. And so then I pull out the 1/4 and I take the derivative of this right here. I'm going to distribute this first. This is really 1/4 times the derivative of x squared plus 5x to the negative 1. You with me so far? And we've done so much work. You feel like you've zipped your pants. I know the feeling, okay? But have we even taken the derivative? We haven't even done the calculus. Okay, so let's do the calculus. So the calculus is 2x minus 5x to the negative 2. Did you get the same thing I got? Okay, but guys, the slope cannot be like with x's in it. The slope, so this is y prime. The slope must be a number. How do I change this to a number? Plug in what? 1 for what? X. Everywhere there's an x for 1. I don't know why, but a lot of students will set this equal to 0. If you set this equal to 0, what you're doing is you're saying this slope is equal to 0. First of all, I know I just drew a random picture, but does that slope equal to 0? Like, you don't know what that's equal to. So the only time you'd set this equal to 0, if I said you had a horizontal tangent line. Does that make sense? That's when you set this equal to 0. The equation of the tangent line, you just need to know what the slope is. So everywhere there's an x, I'm going to put in 1. Let me rewrite this. This right here is 5 over x squared. You guys okay with that? So this is really 2 minus 5 over 1, which is really just 5. And so this I'm getting is negative 3 over 4. Let me check my work. Okay, it's negative 3 over 4. So I have a number for the slope. I have a number for the x and y. That's my goal. Okay, so now I'm going to plug in. I'm going to plug into the point slope formula of a line, okay, which is really y minus y is equal to the slope times x minus x. You guys are just going to memorize this. This is a point slope formula for a line. Before you memorize this, you memorize this, y equals mx plus b, okay? This is the y-intercept, slope y-intercept form for a line. There's different forms for a line, all right? I'm going to plug in the x and the y. Everywhere there's a y, I'm going to put in 3 halves. I'm sorry. Oh, for this y, I'm going to put in 3 halves. For this x, I'm going to put in 1. If you wanted to, you could replace this y and this x. You just have to be consistent. You can't replace the second y and the first x, if that makes any sense. Okay, you got to replace these. If you replace the first y and the first x, it just gives you more problems because you're going to have to solve for y and you'll have a negative y that you have to solve for. So we're just being smart and we're replacing the second ones. But I'm just saying, if you wanted to replace the first one, as long as you were being consistent, you would be totally okay. So I'm going to plug in my slope also, and this is my answer. The problem is my MATLAB wants it in y equals mx plus c format. Okay, so all you do is you solve for y here. Okay, so I'm going to distribute this here. So this is y. Oh, good, Miriam woke up. So we can, just when we do new stuff. Okay, so you're going to, oops, this is an x. Negative 3/4 x plus 3/4. Actually, Miriam, that is on my recording from now on. I'm recording this. Okay, so, and then I'm going to add 3/2 to both sides. So this will be y equals negative 3/4 x. I need a common denominator here, so get a common denominator of 4, so that will be 6. So that's going to be plus 9 over 4. Austin, I hope that's right. So, okay, any questions on this? If you had trouble with this, yours is going to be similar, but with different numbers. Does anyone want to see number 4? Are you good with it? Okay, let's look at number 4. Shika, what's your number here? What's your equation?
I actually can just do it.
Oh, you okay? Yeah, we can do yours.
It's y equals 2x to the 4
2x to the 4
minus 24x to the 3rd plus 9.
Okay. So you want the horizontal tangent line here. So guys, I don't know what this thing looks like, okay? But I know it's a fourth, what do you call it? Degree curve, so something like that. And I know that I want to know where all the horizontal tangent lines are. So if you looked at this curve, do you see where all the horizontal tangent lines are? What is the derivative of every horizontal tangent line? 0, okay? So what I'm going to do is I'm going to find all the places where the derivative is 0. So find the derivative of this. 72x squared. Tell me if I'm doing something wrong. Then set it equal to 0. So I'm taking the derivative of this. Okay, so do you agree the derivative is 0 here, the derivative is 0 here, and the derivative is 0 here? And then I just go solve for x. So I'm going to go solve for all these x values where this is true. So this is going to be x squared. I can take out 8x squared. So 8x squared, x minus 9 is equal to 0. And so what I get is I'm factoring this, so I have something times something equals 0. And I just want you guys to use your smarts. If I tell you something times something equals 0, what do you know about one of those somethings? One of them has to be 0. That's a math rule. There's no way you can multiply two numbers and not get 0 unless one of them is 0. Okay? And so what I'm going to do is I'm going to say either this is equal to 0 or this is equal to 0. So either this is equal to 0 or this is equal to 0. Over here, I get x equals 0. Over here, I get x equal to 9. And I think that's it. Just plug in right there, 0 or 9. Okay? Put a comma in between. All right, what other questions did you guys have on your homework? Okay, let's move to product rule. Okay, so guys, before today, okay, every problem that we gave you, you didn't have to use product rule. But now there are going to be some problems where you might use power rule, you might use product rule. And if you had a plus sign here, okay, you would just do the sum and difference rule. It would just be two terms strung together with a plus sign. You thought you got to do one problem, but oh boy, you get to do two, okay? But if this is a multiplication in between, okay, you can't do that. You can no longer distribute this derivative anymore if these are being multiplied. If they're being added or subtracted, you can't, okay? And in limit land, you can. In limit land, if this had been the limit as x goes to 2, you can distribute in multiplication, but not in derivative land. Okay, in derivative land, so you guys can write this formula down. In derivative land, when two expressions with x's are multiplied together, you have to use what's called the product rule. And the product rule is, it's the derivative of the first. Do you have the notes, Austin? Okay, it's the derivative of the first times the second, okay, plus the derivative of the second times the first. Okay, so let me show you how to use this. So you have this problem somewhere on your paper, y equals x squared minus 2x plus 1 times x cubed minus 1. They tell you to find y prime, okay? So I don't know if you see this, but this is going to be your first, this is your first x expression, so we'll call this your first. And then this right here will be your second, we'll call this your second, all right? This is the first times the second. If you wanted to, you could FOIL all this out. Okay, you could FOIL it, get rid of all the parentheses, then you would just have, something with x plus something with x minus something with x, you know what I'm saying? And then that would be an awesome problem because you thought you got to do one problem, but oh boy, oh boy, oh boy, oh boy, oh boy, there'd be like 7 oh boys. Does that make sense? And you would just go to town, okay? But let's say you don't have time for that, okay? We can do what's called the product rule. And the product rule would be like this. First, you decide what's your first and your second. They're being multiplied together. You take the derivative of the first times the second. See, this is multiplication. Times the second means don't take the derivative, just copy it down. Then there's a plus sign. Then you take the derivative of the second, so that's 3x squared, times the first. And the first means you don't do anything with it, you just copy it down. Okay? And if you want, you can simplify this, but there's some things I need you to do regarding simplification, but I'm very happy if you just leave this just like that. Everybody good at that? That is your answer. If you look at my solutions, sometimes you'll see I'll go a lot further, but this is all I need you to do. I'm picky about some things, like if you have minus times minus, I need you to say that that's plus. If you have plus times minus, I need you to say that it's minus. I'm picky about some things. If you have 2 times 3x, I want you to say that that's 6x, okay? But if it's something like this, I'm good if you just leave it like that, okay? All right, so this is the product rule. The way we remember the product rule is we say the derivative of the first times the second plus the derivative of the second times the first. No. Okay. I do my best. Okay. The hard thing about derivatives isn't actually taking the derivative. It's actually trying to figure out the rule. Okay, do I use the power rule, or the product rule, or the quotient rule, or the chain rule, which we're going to learn tomorrow? Okay, and then after I cry, which rule do I use? Okay, there's so many things you could do. Okay, so, huh? Okay, Monday. Okay, so after the performance. Okay, so if you guys look at these two, and maybe it's easy for you, maybe it's not. Which one do you have to use the product rule on? The second one, because it has 2 x expressions, okay? Here's the first x expression, and here's the second x expression, and they are being multiplied together, okay? Over here, you don't have to use a product rule, but what I want to tell you is this. If you accidentally use a product rule, you'll still get the right answer, and that should bring some comfort to you. You might not finish the test, but you'll get the right answer, okay? So let me look at this. Let's say you guys know you don't have to use a product rule here, okay? So let me just do it without the product rule. You guys know that this is a coefficient. The 2 is a factor. It's being multiplied by sign. It's being multiplied by everything there, okay? So I can actually take the 2 out. So let me just say this is really 2 times the derivative of sine x. You agree with that? Because you can take the 2 out if it's a coefficient being multiplied by everything. Had there been a plus sign here, you wouldn't have been able to do that, okay? So I take the 2 out, and then I say, okay, what's the derivative of sine x? Do you remember what the derivative of sine x is? Cosine x. So I'm going to multiply this, and make sure you understand this is a multiplication. So multiplied by cosine x times the derivative of x, but that's just 1, so I won't put that. And so what I did was just, the plain, I guess not really a power rule, but just the plain derivative that we already know how to do, okay? Let's say I looked at this and I said, I don't really know when I should use the product rule or not, okay? Well, just stay consistent. Call that your first, okay? Call this your second. Are they being multiplied together? Yes, okay, let's try it. So if you do the product rule, what you do is you take the derivative of the first. What is the derivative of 2? 0, okay? Times the second. Times the second means just copy it down. Then you put a plus sign, the derivative of the first times the second plus. Then you add the derivative of the second. So what's the derivative of sine x? Cosine x times the derivative of x, but that's just 1, okay? And then you multiply by the first, not the derivative of the first, just the first, so that would be 2, okay? So the derivative of the first times the second plus the derivative of the second times the first. Is this answer the same as that answer? It is, because 0 times anything is 0. And this, remember I told you a lot of times I move the 2 to the front. And it's the exact same answer. So that should bring you some sense of comfort that if you have no idea what you're doing, okay, you can probably still muddle through it. All right, let's go over here to 2x sine x where you don't have a choice. Okay, so let's go ahead and take the derivative of this expression over here. So this will be the derivative of the first times the second. Times the second means just copy it down. All right, but this is all multiplication plus the derivative of the second. What is the derivative of sine? Cosine. So this will be cosine x, and then, just copy the x times the derivative of x. That's just 1, so I don't have to do that. Okay, and so the derivative of the first times the second plus the derivative of the second times the first. And make sure you know this 2x, okay, is being multiplied by this whole cosine x, not just this x here, okay? And a lot of times students will multiply the x and the 2x and put 2x squared, and then it becomes wrong. And so if you put this answer right here, this would be a great answer. I would give you 100%. I like to move the 2x to the front, just so I don't accidentally multiply it with the x. But both of these are 100% great answers. All right? Yes. Yes. Okay, so you guys do this one. So you guys know how to take the derivative with product rule now. You guys do that. This is easy for you. So go ahead and start your homework. Go ahead and find the product rules on your homework. Go ahead and start it. Homework is expanded math. Okay. So this will be, figure out what your first is, figure out what your second is. Now, I'm going to throw this in there, and it may confuse you, but I'm just going to throw this in here. Do you see that the 3 is a coefficient being multiplied by everything in here? It's a factor. So you could pull out the 3, just take the derivative of the x squared sine x with product rule, and then push the 3 back in. But when you push the 3 back in, it becomes like you have to distribute it. Okay, so it's a lot easier just to make the 3 the part of the first. It's a lot easier. Okay, so I'm just going to make the 3 a part of the first expression. So here we go. The derivative of the first times the second plus the derivative of the second. The derivative of sine is cosine x. S does not start with a C, so I'm not going to change the sign. And then times the second. So let me make sure I did this right. The derivative of the first times the second plus the derivative of the second times the first. Feel good about that? And then once again, if you want to, you can move this 3x squared right here. Whatever you do, don't multiply the x and the 3x squared. Okay? Any questions? All right. You also have what's called the quotient rule. Okay? So the quotient rule is when you have a fraction here. In limit land, if you wanted to take the limit of one x expression over the other, that is equal to the limit of the top divided by the limit of the bottom. You cannot do that in derivative land, okay? In derivative land, if you have the derivative of something divided by something else, it's just not the derivative of the top divided by derivative of the bottom. That's what a lot of students will do on their test, okay? It's not how you do it. You have to use the quotient rule. And the quotient rule is, it's very similar to the product rule, except different. It goes like this. The derivative of the first times the second, okay? But do you see instead of a plus, what do you have? Minus. The derivative of the second times the first. So you kind of feel good about it, right? It's very similar to the product rule. So go ahead and write this down if you haven't already. It's the derivative of the first times the second minus the derivative of the second times the first. fraction. So then I always say it's all over, and then whatever is on the bottom here, you take that whole thing and you square it. Okay. Does the bottom have a derivative? No. It's just you grab it and you square it. Okay. And this is the formula for a quotient rule. So let's go ahead and do the problem for the quotient rule. So this is a quotient rule problem. Okay. Let me show you some things that students do wrong if they see this on a test. Some students will say, hey, let me take the x and put it up. Okay. You can't grab this x unless it's being multiplied by the whole thing. Okay. And the x is only being multiplied by the 2. You see that? It's not being multiplied by the 7. And the problem is this minus sign in here. So you cannot take that x up. Okay. What you can do, if you wanted to take this thing up, you could take this whole thing up like this. You could do that. And that would be a viable way to do this. The only thing is, at this point, to take this derivative, you need chain rule, and you don't know how to do that yet. But tomorrow, okay, you will be enlightened, okay, and you'll be able to do every single problem after we use the chain rule, okay. But today, this one, you're pretty much stuck with the quotient rule, so let's figure out how to do this. This will be the first, okay. I'm going to call this the second. And please, once you like the first has to be your whole top, the second has to be your whole bottom. You can't just take parts of it and decide, I really only want to take the derivative of, part of it, not the whole thing. Like, that's not a choice. Okay, so here we go. You're going to do the derivative of the first times the second, the whole second, minus, this is a quotient rule, the derivative of the second. What is the derivative of 7 minus 2x? Negative 2 times the first. Let me check this. The derivative of the first times the second minus the derivative of the second times the first all over, okay? And what is it all over? The entire second, the entire bottom square, okay? Do not take the derivative at the bottom. You just take the whole thing, whatever it is, quantity it, and square it, all right? This is a great answer. It's not a 100% answer. I don't like negatives here, so I do require you to make that a positive, okay? If you don't make that a positive, I'll just be like, well, he didn't know that negative times negative. Negative 1 times negative 2 is positive. Well, I'm just going to pick off a point, okay? But other than that, this is a great answer, okay? Again, when you guys look at my solutions, I might have gone further than that, but that's just me, okay? All right, let's look at this problem here. This one here, you're going to have to rewrite before it becomes very easy. What do you think that I would suggest you rewrite? The 1 over x. How would I rewrite that? Yeah, x to the negative 1. If you change that to x to the negative 1, that's going to make your whole life easier here. Okay, so I'm going to go ahead and take the derivative here. It is a fraction, so I'm going to use quotient rule. My top, I don't know what this is, my top factor, whatever this is 3 minus x to the negative 1. On the bottom, I have x plus 5. So this will be the derivative of the first. What did you guys get for the derivative of the first? 1 times 1, carry down your x, and now the new power is negative 2. So the derivative of the first times the second, make sure you multiply by the whole second. This is a quotient rule, so now you're not going to put a plus. What are you going to do? Minus the derivative of the first times the second minus the derivative of the second. What is the derivative of x plus 5? 1, okay, times the first all over the entire bottom, quantity it, and square it, okay? And so this problem here, the only thing that I would ask you to do if you're on a test is take out the 1, because 1 times anything is itself, and I expect you to know that, okay? So that's how I expect you to simplify. All the other things I don't expect you to simplify, okay? All right, let's go to this problem. Lots of ways to do this problem. I think the most common way that students would approach it is the quotient rule. You don't have to use a quotient rule, though. You may or may not see this, but 1/6 is actually a coefficient. You may or may not see it. I don't expect you to see it, but if you do see it, if you do see that this is exactly the same as this. Another way I think about it is that numerators bounce out, so I'm just bouncing this numerator out, okay? If you see it like this, it's very easy actually to do the derivative, okay? The derivative here, f prime of x would be equal to, remember, this is a coefficient that's being multiplied by everything else. It's a factor, 1/6 times x squared plus 3x times whatever, all of this. So this would be 1/6. You could pull it out, and you just multiply by the derivative. See how easy that is? And that's a great answer. Okay, that'd be a fast answer. But I got to tell you, on the test, most students don't do this, which is totally fine. Okay, on the test, most people see this as a quotient rule. And I just want to show you that if you did the quotient rule, you would get the same thing, except that you have to do it right. Okay, so if I call this the first and I call this the second, let's do it. The derivative of the first times the second, okay, what sign goes here? Minus the derivative of the second. What's the derivative of 6? 0 times the first. And I want to say, I know some of you guys are saying, oh no, on the test, I'll remember to pull out the 1/6. But I want to say only like 2 students out of all my students will do that. Okay, so very few students will see that you just pull out the 1/6 on this. So we're going to do the derivative of the first times the second minus the derivative of the second times the first all over 36. You see where I'm getting at 36? Okay, this right here goes to 0. Are you good with that? And I would strongly suggest, even if you know things go to 0, write out everything on your paper. Because what happens is a lot of times this first term will go to 0 and the second term doesn't. And then students will not write the first term. And then they lose this minus sign. Okay, and then they can't even get partial credit. Okay, so what I'm telling you is, at least for the first step, write everything that you know as the formula goes. Okay, then start simplifying. Don't simplify as you go along, is what I'm saying. Okay, so then what I get is this is 0. So then this right here becomes 2x plus 3 times 6 over 36. And this is the derivative. Right here, do you see what simplifies here? Yeah, this simplifies 1/6. Now, had there been a plus sign here, you guys get that I couldn't simplify it. But it's because the 6 is being multiplied. It's a factor. It's being multiplied by everything else. And the 36 is being multiplied by everything because it's by itself. So this becomes 1/6 times 2x plus 3. And was that the same answer I had when I had pulled out the 1/6? Yes. Okay. So again, if you use product rule and you didn't have to, you still won't get it wrong. So there's no reason to worry. You just need to worry that you did the product rule or the quotient rule correctly. That's it. Okay. All right. And then finally, before we go too far, I'm just going to show you some notation. This right here is how you say the second derivative. You already know that. These are second derivatives. Sometimes when you see a third derivative or a fourth derivative or a fifth derivative, they'll put like the number in parentheses here. So this is like the third derivative of that. And then this is the second derivative. So this is really saying the derivative of dy dx. This is already a derivative. You're taking a derivative of a derivative. And do you see how there's 2 d's here? That's where the squared came from. And do you see how there's 2 dx's here? That's where this squared came from. Like they don't put a parentheses here. This is just notation so that you don't freak out when you see it, but this is just saying the second derivative. Okay? All right. The final thing I want to talk to you guys about is when we take the derivative of trig functions. Okay? If you want the derivative of tangent, actually, I'm not gonna. I was gonna like do it all for you, but let me just tell you, you're gonna have to change this to sine x over cosine x, and use the quotient rule. And if you want to do it on your own, or you can, I was gonna say you can watch my video, but this is gonna be my new video. Okay, so if you do this, what you'll get is the derivative of tangent is actually secant squared. So secant x quantity squared. That is a derivative of tangent. Okay. Also, that's the same thing as secant squared x. Right? You're just going to have to memorize this eventually. And so you're gonna memorize this whole table here, this whole table here. If you have time, can you guys go ahead and jot that down? And you're gonna have this in your memory, like this will be a formula quiz, okay? Right now, I'm just putting x's there. I'm not putting 2x or x squared, so we don't have to have the multiplied by the derivative on the end, okay? Because the derivative of x is just 1. Notice that anytime you have a derivative that starts with a c, you change the sign. Okay, so you can always remember that. If it starts with a c, you change the sign. Okay? Oops, I don't know what that is. Okay, good. Okay, I'll post this, guys, because I know we're kind of running out of time. So I'll post this. But let me show you how to do this. Okay, if you have a quotient rule, okay, and you have one of these trig functions, and you wanted to find the derivative, it's going to be the derivative of the first. So what's the derivative of secant x? The derivative of secant x is secant x tangent x. So you're going to say the derivative of the first times the second. Okay, this is a quotient, so it's minus the derivative of the second times the first all over the bottom squared. Yes, you have to do that. And that's your answer. The only thing I'd ask you to do is take out that 1. Okay, because I want you to know that 1 times secant x is just secant x. Okay? The other thing I want you to be able to do is if you look at this table right here, okay, or not the table, this graph, and they ask you to find the derivative of h, they tell you that h is one x expression times another x expression. What they're saying is you have to do FDA, okay? Don't plug in your 1 first, okay? Take the derivative of 2 things multiplied together. If you multiply f and g and you take the derivative, guess what rule you have to use? Product. So it's the derivative of the first times the second plus the derivative of the second times the first. And then in your A, that's a derivative, then you plug in your number. So what did you plug in for x here? 1. So everywhere there's an x, now I'm going to plug in 1. And then usually they give you a table or a graph to figure out all these numbers. So you'll just go to your graph. This one's f and this one's g. So then the question is, what's f prime at 1? Go find 1, and f prime is a slope, right? So go find the slope of f at 1. What slope do you get right there? 2. So this is going to be 2. G of 1, that means go find your g curve. What is the y value at 1? 3. So 2 times 3 plus. G prime at 1, that means go to your 1, go find your g curve, and tell me the slope. What's your slope right there? -1. Some of you guys aren't writing things down. I guess you'll just do it at home. And then F1, so F is this curve right here. If you plug in your 1, what is your F value? I'm getting 3. 3. You guys see that? Okay, so that's going to be 6 minus 3, and this answer is 3. Okay? If they ask you for a quotient, so look, if they say find k prime of 6, but then they say k is f divided by g. Do you see they're just giving us the quotient rule? So you would write for this one, again, FDA, the k prime is the derivative of the first times the second minus the derivative of the second times the first over the whole bottom square. Now I can take a picture of this, okay? But that's how you'll do quotient rules, okay? And that is your homework. Make it a great day, guys.